Welcome back to the show. I'm here with David Tattersall, co-founder of Integral and makers of Fusion Reactor. And today we're talking about what's new in the freshly released Fusion Reactor 7 with over 20 new features in it. And we're going to be doing a demo later in this, which we'll be talking through. So those of you who are listening by audio will be able to get all the exciting stuff. And welcome, David.
Thank you, Michael. Thanks for having me.
So just for the people who haven't heard of it, what exactly is Fusion Reactor?
So Fusion Reactor is a lightweight application performance monitor. It supports all the major Java containers, Tomcat, Jetty, WebSphere, JBoss, of course, Wildfly, also ColdFusion. So Fusion Reactor has been around since 2005 now. And we are the #1 monitoring solution for ColdFusion.
So basically, if you have a ColdFusion server that's slow or crashing, you want to have Fusion Reactor to help figure out what's going on. Absolutely. Or prevent it.
Absolutely, yeah. So there's two main areas that we focus on. There's performance-related issues, or there's some defect in the code, a bug in the code that you're trying to find out. And as you rightly say, so the job of the monitor, generally monitors do two things. They measure and they alert. So measure is in terms of metrics, so things like web requests, JDBC activity, memory, CPU, all the metrics in and around there. And they would alert you to, say, for example, a slow running request, or if you're running out of memory. And Fusion Reactor does all that. And on top of that, there's two key differentiators that Fusion Reactor has. On the one side, we do something called crash protection. So when we recognize that something's going wrong with your application server instance, then we will try and take some preventive action to basically enhance the resilience of the system. So we're not doing things that is necessarily going ahead and fixing the issue, but we're taking some proactive action in order to try and ease the situation. So an example of that could be, let's say you've got a long-running request, and maybe on your system you say no request should run longer than 10 seconds. So if you have a request that runs longer than 10 seconds, then you'd like to kill it. So Fusion Reactor will actually attempt to kill that request in that particular case. The other area where we differentiate is we've got a number of production analysis tools. So we've got a debugger, we've got a code profiler, and with the advent of Fusion Reactor 7, we've now introduced our new memory profiler. And all these tools are basically, these are what you say would be typical developer tools, which normally you wouldn't use in a production environment. But we've made these tools available to be used on a production environment. They are very safe, very secure, and extremely low overhead. So Fusion Reactor still takes just less than 1% of your CPU, your system CPU, or your instance CPU when monitoring a server instance. And that's our goal, to keep that overhead at less than 1%. So having the availability of tools, like I said, debugger, code profiler, memory profiler, the idea is that with those tools, these are familiar to developers, and they're going to let you get down to the root of your problems as fast as possible. And that's essentially what we're all about, getting to the root of the problem. So,
all right.
Okay.
Well, is it time to have a look at the newly released Fusion Reactor 7?
I think it is. If you just bear with me, can you see? I've shared my screen now. Can you see my screen there?
I'm sure it's coming up if you're seeing it at your end. So when did Fusion Reactor 7 release?
Fusion Reactor, that should be it. Should be coming up now. So where did we release, or what, sorry, what was the question?
How long ago did it release?
Okay, so we had the launch. Actually, it was on the 2nd of August, and we did what we always do. So basically, we term this sort of a soft release, and we always bring Fusion Reactor out, and then we let people know through the social channels, through our Facebook accounts and through Twitter. And then gradually over the next, usually over the next week, we mail out to all the customers who have either got subscription licenses or they've got a valid maintenance license that the new version's available. And then we start sort of pushing information out to, let's say, the rest of the world. So we sort of start really opening it up and marketing it then. Yeah, we've got, we've got over 5,000 customers. We've got well in excess of 25,000 servers running Fusion Reactor. We also want to make sure that in the case that there would be anything, any problem that would come up, that we're able to pick that up very, very quickly. And this is especially important for a major release because there's been so many new changes. And what happened this time was a customer contacted us. They were running ColdFusion 7 with a older Oracle JDBC driver, and that causes a problem. And we basically isolated the issue, fixed it, and pushed a new version of Fusion Reactor all within a couple of hours. And since then, everything looks good. But, these things can happen. We've got, if you think with all the different Java containers that we're supporting, different versions of C, CF, also with Rilo and Lucy, there's all these different combinations of environments. There's literally thousands and thousands of different combinations. And as Fusion Reactor really goes so deep inside the JVM, it's at the end of the day, it's software. And it's very difficult to test every single platform. I think we do a great job with that, but things can always happen. Okay.
All right. So I'm excited to see the new features in Fusion Reactor 7.
Okay, me too. Okay, so that's me again. My name is David Tattersall, CEO, co-founder of Integral. I'm just going to throw a few slides up here, give you some highlights. Again, I'll probably skip the what is Fusion Reactor because we talked about it before, and I'll probably just jump straight into the demonstration so that you can see that. Real quick, Fusion Reactor 1 was launched in December 2005. We've just launched Fusion Reactor 7 last week, and Fusion Reactor Cloud is planned for full launch in 2017. So it is currently available. You can currently purchase it if you come to us directly. We're not selling it until we actually do the official launch via the web store, but as soon as we do launch, then you will be able to purchase it directly through the web store. But if you'd like to try out Fusion Reactor Cloud right now, just drop an email into sales@fusion-reactor.com and we can set you up with a trial account, and that won't be a problem. So like I say, we've got over 5,000 customers who purchase Fusion Reactor really across almost all industries and segments. And we've got somewhere in excess of, I'd say between 25 to 30,000 servers now running Fusion Reactor. On cloud, we're already processing billions of transactions per month. So we already have a number of customers who are already using Fusion Reactor Cloud. Like I said, we're the global market leader for Adobe server products for monitoring. Obviously, that's ColdFusion. But as you know, Fusion Reactor is a Java monitor, And we also support all the various different Java containers. And I'm very proud to say that Fusion Reactor won the 2017 FIFO Gold Trusted Award. So we've got a rating of 4.8 with 175 reviews. We've actually got, I think, since I did this slide, we've got 185 reviews. Those are going up all the time. And we were very proud to win that award this year.
Well, congratulations.
Thank you very much. So, like I said, FR is a low overhead Java monitoring tool. The idea being that it's going to give developers total insight into how their code executes and performs at production runtime. And I mentioned before, we've got two really unique features which differentiate Fusion Reactor from all the other APM tools. First thing is we increase application resilience with crash protection. And the other real key differentiator is that we've got our program analysis tools of the Debugger, the Code Profiler, and the Memory Analyzer, which are all integrated into Fusion Reactor, low overhead and production safe.
All right.
Okay. So this is sort of a quick overview of what I'm going to show. So I'll go through the main core features and also the Fusion Reactor Ultimate features. And time's not actually permitting today to go over Fusion Reactor Cloud, so I've grayed that out. I will do that on a subsequent video though. So I'd be happy to do that with you, Michael.
Great.
Great. Okay.
Well, let's have a look at some of these metrics that you've added in.
Right. Let's take a look. Okay. So can you see that screen okay?
Yeah, it's a little teeny tiny, but yep.
Little teeny tiny. Okay. Well, it's full screen for me. So big monitor here.
Got it.
Got it. Okay.
Well, talk us through what it's showing, so just in case people are having trouble reading it.
So what you can see here, this is one of the main screens that we've got in Fusion Reactor. This is the Web Metrics screen. And I've got a couple of applications running in the background here just to add a little bit of noise onto my server so that we can see some transactions and some JDBC activity taking place. And what I can see here at the top left-hand side are web requests. So you can see the number of requests going through per second. Next to that, I've got JDBC activity. So again, I can see the number of JDBC requests which are being processed per second. And on the right-hand side, I can see the two main system resources, which are memory and CPU. And if I scroll down to the bottom of the screen here, I also get some overview of how long the server's been.
And that's basically database requests.
Yep, those are database requests. And I'll show you some of the details there in a sec. But I can see here how much memory is being used in total, how many requests have gone through, what JDBC requests are currently running. I can see whether there are any slow pages, recent slow pages, or also whether crash protection is triggered. And we can see here in this particular case, I did have one crash protection request aboard, and we'll take a look at that one in a sec. So some of the new features in Fusion Reactor 7, what we've done is we've introduced JMX Bean. So JMX, for those of you who are not familiar with that, those are Java management extensions. And when I open up the JMX Beans or MBeans page, what I see here is a breakdown of all the MBeans which are available on this particular system. And MBeans are essentially unlimited. So if you've got an application, you can expose MBeans to JMX, and those MBeans then usually include some sort of attributes, and those attributes can be interrogated. And if we look here, so I've just opened up operating system. I can see I've got a bunch of attributes. I'm not sure whether you can read all those, but things like free physical memory space, max file description counts, process CPU load, system CPU load. There's literally, just within the operating system itself, there are hundreds of attributes available. And like I said, pretty much it's unlimited. So if we introduced, let's say we were using Kafka on this particular server instance, then all the Kafka MBeans would be available, and you'd automatically, Fusion Reactor is interrogating the JVM for those MBeans, and you would automatically see them here. And down at the side, you can see there's a little control here, and these controls are what I would use to select those attributes. And if I select them, you can see I've got a couple here. There's process CPU load and system CPU load. And next to that is a link to CloudWatch. And this is another enhancement that or another new feature that we've introduced with Fusion Reactor 7. So we've introduced the capability to push both Fusion Reactor Metrics and JMX MBeans up to AWS CloudWatch. Now, AWS CloudWatch is also a monitoring tool, which is made available from Amazon. But as far as I know, Fusion Reactor is the only product which would seamlessly enable you to push instrumentation data, so metrics, especially JMX beans, directly from the JVM and directly into CloudWatch. And if I go here, I can see in my MBean overview, these are the beans that I've got available. And like I said, some of these are graph related. So if I click on that, I will see a specific graph, and I can look back here across 1 hour, 1 day, and 1 week, just like usual in Fusion Reactor. But I can also take a look at AWS CloudWatch metrics, and this is the interface to AWS CloudWatch. And here you can see all the variable, all the different series or metrics which are available through Fusion Reactor and through the JMX metrics, which you can very, very simply add to CloudWatch. And as long as you've got an AWS CloudWatch account, then those metrics will be automatically posted to AWS CloudWatch. So like I said, that's a pretty neat thing. It enables Fusion Reactor to be used as a telemetry tool to capture metrics, push them to CloudWatch, and we've also introduced all the JMX MBean metrics. So let's take a look at what sort of requests would look like. And I've just gone here into my history, and here I see the last 100 requests which have been executed. And if I just go down here, I've got a request here called add to cart. So like I said, I've got a couple of applications running in the background. And if I drill into that one, this is typically what you'd see in the Fusion Reactor transaction details screen or request details screen. You'll see all the request details. So for example, what the URL was, what the IP address was that called this, the status code. I can see the execution time. I can see how much memory this request used. If this particular request had any JDBC activity, I can see here how many queries were executed. I can also see things like header information. I can see whether there are any cookies used. If I click into JDBC, we'll get a complete breakdown of the SQL that was used. This was Hibernate call here. I can also see the data source, which was referenced for this particular request. And I can see the total time, the DB time, and how many rows were actually returned in this request. So this is really useful. Very often, you know, performance issues are embedded in the JDBC, and just by going into the details here and seeing, oh, you know, for this particular SQL command, you know, we're returning 5 million rows. Do we really need to do that? You know, should we have some workflows on that select statement? Probably. We can also see things like relations, which is also very useful for performance tuning. So this gives us a visual breakdown of this particular request. So I can see I've got, we're using Spring. This is Java Spring framework here. And what this relations breakdown gives us is a visual breakdown of the core components of this particular request. And I can also see in the transaction hierarchy here, I can also see individual details, and I can drill into the actual transaction components of this request in order to get more information. So again, really useful breakdown here of what actually exactly happened on this request. And under the requests, you can see there's a bunch of different menu items here. Some of the useful ones are things like slow requests, so I can see which particular requests ran for the longest amount of time. Another really useful one is requests by memory. So this is showing me how much memory I allocated per request. And again, this is something that you don't always see in many monitors, but this is actually a really useful metric, because sometimes certain requests are using a ton of memory and we're not even aware of it, and that memory consumption is then leading the application server to run out of memory. And as I'm sure you know, memory is very often an issue. And you can see here we've got application and transaction. And on this particular request, if I drill into this one, this is this Fusion Reactor Spring test application. If I drill into that, then this also gives me a very interesting view in Fusion Reactor. So this is our application screen. And what this is showing is a breakdown of my application. So not just focused at specific requests or transactions, but what we're able to do is we're able to analyze an application through the URLs and extract it. For example, if you're using a framework, based on the actions which that framework is using, will actually auto-detect the actions. And as you can see in this Spring test application, we've got a number of actions here. For example, destroy session, login page, add to cart, and we're able to provide metric data on how many times those particular actions were called, whether it was a get or a post, how much memory is being used, what the duration of that request was, so how long it ran for, how many times it was executed, how much CPU it used, etc., etc. So this is a really, really useful screen to give you sort of an application-focused view of your application, and very, very useful in performance tuning.
So we're looking at this one, David. It says this long JDBD task took up 73% of the time.
Transaction time, yeah. And the reason for that is because if I go under JDBC and I look in longest transactions, then you can see this long JDBC is actually on this particular demo application. I'm just running sleep statements. So this is, you know, for a demo, it gives you sort of the demo effect here. Obviously, normally you wouldn't run a select sleep for 8 seconds. We're just basically doing this just to put some, I'm using Apache JMeter, and this sleep statement is just part of the script that I'm running. So this does give, well, it's a true, obviously the metrics are exactly dead on. We did run 75% of our requests were these sleeps, but obviously that wouldn't happen on a typical system. So, and if I drill into these, you know, and I look at the JDBC, it tells me exactly that I got a select PG sleep 8. So, yeah. In some ways, it's perfect because it's telling us exactly what's going on, but it's, you know, it's not something that you necessarily have in your applications. One other thing I wanted to mention about applications which relates to ColdFusion is that we've extended Fusion Reactor 7 now to include specific instrumentation for a number of frameworks. So we've got ColdBox, which we'd had for a while, but we've also extended it now with Framework 1 and also with Fusion. So for those frameworks, we'll be able to automatically detect the various different actions that that are included in those frameworks. And you'd see then on this particular page, you'd see a breakdown of which framework actions have been executed. What else have we got? So we also do something which is, I'd say, fairly standard for a serious application performance monitor, and that's user experience monitoring. And user experience monitoring is measuring the end-to-end performance of a request. So you can see here we're measuring database time, we're measuring web request time, so time on the server. The orange is time on the network, and green is client rendering time. And see here, we're showing basically, so for this particular system, we've got an average of something like 500 milliseconds, so around about half a second, with the majority of time being spent on the network. So very often, you know, people will be sat in the war room and the customer's contacted you and said, you know, your application's slow, and then you get finger pointing because, you know, the DB guy says it's not me, the network guy said it's not me, obviously it's not the web request, you know, it's never the developer. And with the UEM screen, this is basically, you know, we getting away from finger pointing here because we can just look at this and say, okay, we're all good guys. It looks like the issue is the network. So that's a pretty useful feature. What we've also got is session monitoring. So you can see here sessions being created, sessions being destroyed, and the total number of active sessions which we've got. This is sort of pretty stable around about high 380, 390 sessions. We can also see those sessions tracked by applications if we wanted to track. So if we got multiple applications being monitored by Fusion Reactor, then we could click here on the track button, and those applications would be automatically tracked and the sessions would be tracked. So sometimes, you know, people don't realize, if you ask them, you know, how many sessions do you have? They say, oh, you know, we've usually got, you know, maybe half a dozen users using the system. But what they are not aware of is that they've actually been tracking sessions. They've left tracking sessions on. The sessions have not been culled, and they've, you know, sometimes got a ton of session variables, so that's eating up memory. And you've not got half a dozen sessions, but, you know, sometimes you've got several thousand sessions, which you're still maintaining, or that ColdFusion's still maintaining. So Fusion Reactor would be able to show that to you. Okay, so what else have we got? Let's take a look under resources. So this is pretty important area. So here you can see things like Heap, non-Heap. You can see various different memory spaces. So Eden space, old gen, perm gen, survivor space. These are the different Java memory spaces, and depending on the JVM where you're running Fusion Reactor, you may see different memory spaces highlighted here. So I'm running Tomcat 7, and this is what's come up from Tomcat 7. Very useful information. Very often, like I said, issues are related to memory, and Fusion Reactor is able to show you memory profile, and also, again, across a day or up to a week's time. You can also see things like GC, the garbage collection. So you can see here, we've got scavengers running off here. That the GC is running. I can see memory being freed. Again, I can go back over the last hour to see what's been going on. And I can even actually run a garbage collection. So you'll see down here at the bottom right-hand side, there's a garbage collection button. If I click that, then up at the top, it tells me how much memory has been freed. So sometimes people believe that you know, the problem lies with the garbage collector, and that's the reason why their system's breaking. So they go in and try and fiddle with the garbage collector and tune it. That could be an approach. Generally, I'm personally of the opinion that generally the garbage collector is pretty good. It's been optimized for the JVM that you're running on, and obviously as new versions, new releases of the JVM come out, if you've gone in and fiddled with the garbage collector, then there's a very high probability that you'll have probably done something which causes issues for you with the new release of the operating system. So in my opinion, probably better to leave the garbage collector, but it's fine to take a look at what it's doing. Okay, what else have we got? Also under resources, I can also see things like classes, so how many classes were loaded, or class loading in real time. I can also see thread activity, and I can see all the threads which are available to me. So this is also an interesting view here. So these are all the current threads which are available on the system. And if I noticed that I had one that I thought, okay, this one seems to be sticking, I could do a stack trace of it, or actually, if I click the button up here, if you watch that, I can do a stack trace all. And if you saw how quick that was, it's literally, it's less than, well less than a second, and we've got quite a lot of threads here. And Fusion Reactor stack traced every single one of those threads and made that information available. And I don't know if you saw that. If you mouse over here, you'll see these are actually, these are links. And very interestingly, if I click on one of those links, whoa, we just did an instantaneous decompile of method. And obviously very, very useful if you're trying to get to the root of some problem and you saw that something was sticking. All the stack traces that we have, the class and method, well, the lines within the stack trace frames, those can be clicked on, and providing that you've accepted that you're okay to decompile, there's a the first time you invoke it, there's a pop-up there that asks for your permission, but if you provide permission, then we will instantly decompile it. We do have some checks in there. For example, there are a number of programs which we don't decompile, ColdFusion being one of them, obviously. So you can't decompile ColdFusion, but if it's your own code or something in Java, then it would enable you to decompile that.
Wow.
Very useful feature. Okay, so what else have we got? We've also got a system monitor. So this is sort of not typical really in an application performance monitor. Usually that's focused on the application instance that you're monitoring, but we've extended Fusion Reactor to actually provide metric instrumentation for the actual server itself. So this is giving you instrumentation. I'm running this demo on my laptop, and I've got a VM that this is installed into. But what you can see here is my machine network usage. So this is network I/O or disk I/O, and I can see memory and CPU of my whole my old physical machine here. So not just the virtual machine, not just the instance. And again, we show information like system uptime, which version of Java we're running, also things like processes. So I can take a look at these are all the processes which are running on my machine right now. So again, pretty useful information here. Not focused directly at the actual instance, but very useful metric information to have available. And just there's one thing I just remembered actually when I was showing the metrics before. You may have seen, so a lot of these metrics are, you may be thinking, oh, a lot of this, obviously requests, JDBC, resources looks interesting, but what about ColdFusion? And I've got another Fusion Reactor here, which is actually running, this is running a ColdFusion server, which is also under load. And we've got around about, I think it's about 45 different ColdFusion focus metrics. So from requests to template requests to web service requests, we've got Flash metrics, we've got CFC metrics, we've got DB pool stats. We can also see under CF system metrics, there's a bunch of different things as well. So template cache, CF threads, if any are running, query cache. So there's a bunch of different things there. Some of these metrics actually require the ColdFusion monitoring to be enabled. Not all of them, some of them do. And yeah, if you enable the CF monitoring, which is built into ColdFusion Enterprise Edition, then this information, or some of this information, will also start to appear. So I just wanted to mention that about ColdFusion as well.
This looks great.
Yeah, so like I said, there's two ways that we differentiate. Fusion Reactor from other monitors. And I said the first thing that we've got is something called crash protection. And crash protection, we're doing 3 different things. We're basically measuring quantity, so how many requests have been running. We've got runtime protection, so this is how long has something been running in seconds. And we've got web request memory protection, so when our heap hits a certain threshold, and we can move this thing around. So when our heap has hit a certain threshold for a certain amount of time, then we would also generate either an alert or invoke a protection strategy. And as I mentioned earlier, one protection strategy could be, in the case of runtime protection, we could actually abort a request. With memory protection here, we could either reject or queue requests. So imagine if you've got, if you said if the heap goes over, 98% for a period of 10 minutes, then I fear, my system's going to, it's going to fall over. So in that particular case, I'd like Fusion Reactor to queue requests and not let any more requests in until the heap has corrected itself. So the heap threshold has gone below 98%. So that's crash protection. And if we, like I said, we just had a crash protection event earlier, and that was under, we had a timeout protection, and this was the timeout protection that ran. So I'd got something called write file slow JSP. So I'd set a threshold here about, I think it was about 22 seconds. And I said, if anything runs longer than 22 seconds, I'd like to abort that request. And that's exactly what this did. And if I drill into it, I can see all the request details. And if I go into the error details, this is going to tell me that this thread was killed. And the cause, if I scroll down, was it was invoked by Integral APM, Transaction Assassin, and that's a great name. Thank you, John Hawksley, for coming up with that. The Transaction Assassin will actually kill the request. And just to be clear, it's not possible to kill all requests. If it's a Java native thread, or if it's holding some sort of resource, then you wouldn't be able to kill that thread because that could destabilize the JVM. But we know which types of threads are killable, and this was essentially an application request. So this was some program that we did. So this one was perfectly safe to kill, and Fusion Reactor was able to kill it.
So the idea here is, instead of these zombie requests that are just chewing up your server resources, carrying on and on, the crash protection just kills them after a certain while, so your server doesn't die.
Exactly. Yeah, that's exactly it. And again, it's it's all about resilience. What you don't want to happen is that your server, gets there's a ton of rogue requests running at 3 o'clock in the morning, and your server falls over. So much better, other monitors may send you a warning and say, hey, you've got a bunch of requests here. But, if those requests cause your application to fall over, then it doesn't really help you that much knowing that there was a lot of requests. So this is really an area where, Fusion Reactor comes into its own. And it's the only, as far as I'm aware, it is the only monitor on the market that's got anything like that. And for us, that was, that's been in literally since, we built crash protection, I think, in one of the the 1 point version. So it was really right at the start of the product where we said, you know, if we're inside the JVM anyway, and we're able to monitor this stuff, you know, let's try and keep the application alive. I mean, we'd had applications ourselves. I can't remember whether I told the story about that, about how we built Fusion Reactor, but we were building massive enterprise scale ColdFusion applications. This is back in 2005 when there wasn't, you know, that there wasn't another monitor available. And we said, hey, you know, we want to be able to get inside ColdFusion so we can, you know, figure out exactly what's going on. And that's what drove us to build Fusion. Okay, so how else do we differentiate? Like I said, we've got three tools which really are very unique. The first one I'm going to show you is the profiler. And I've got one request here, and this is actually the request which we killed before. This is the write file slow. But I also, because this ran for, I've got my profiler configured, anything that runs longer than 10 seconds, profile it. And here you can see the profile. And if you take a look at that, what may strike you is that that sort of looks like a stack trace, and the reason for that is because that's how we're generating it. So what we're doing is we're taking stack trace snapshots, and we're aggregating that data together to build a profile picture. So this is what you'd sort of call a statistical profiler. There's different types of profiler. There's line profilers. So there's profilers which will basically show you how much time you're spending on each individual line of code. Obviously, that would be too much of a performance hit for a production environment. But this, our particular profiler, basically takes stack trace snapshots, and those are so quick. A stack trace snapshot in Java takes about 1 millisecond. So we can see here we've got 60 samples. So this particular profile cost in real terms somewhere between about 65 to 70 milliseconds to capture the data and to aggregate it together. And what you can see here is obviously you're going to see your Java methods, because this is built from the stack. But I can see that I'm spending most of my time in Java I/O, and the majority of time was on this file close. And actually what this particular application did, this write file slow, is I've just got I'm just writing file data into a file within a loop, and I'm actually opening and closing the file within the loop. So obviously you wouldn't do that, but that just demonstrates that, you know, the profiler was able to analyze it and highlight that, you know, I was spending the majority of my time on file close. So clearly file close is, it takes more time than a file open, but you know, every developer would be able to look at that and very, very quickly figure it out. Good, so that's the profiler. Very useful tool. Use it for analyzing performance bottlenecks, and you can see here we show you the percentage of time spent in the method and the actual real time in seconds.
So that would let you figure out which parts of your code were running slow.
Exactly. Yeah, that's exactly what you'd use it for. So you're looking for hotspots, basically, in your code. That's what you would use the profiler for. And of course, very often, you know, a hotspot will manifest itself actually in production once it's running against production data. So, you know, I think a lot of people profile their code, but they'll profile it locally in their development environment. And it's only once that code goes into production that you know, the real truth comes out. There is, you know, there's no environment like production. And that's why we believe that having this capability and having these features available in production, this is really, you know, what differentiates Fusion Reactor. So the next feature is the memory profiler, and this is a new feature within Fusion Reactor 7. And I'm not sure whether anybody out there, whether you're familiar with JVM. If you are, this actually looks very, very much like JVM. It's basically, it's profiling the same heap-related data. And I can set a refresh rate here of 1 second. And I'm not sure if you can see that on the video, but because I've got these couple of applications running in the background, my heap is permanently changing. And I can see how many objects have been allocated. I can see the live size. So this is a percentage of memory used on the heap. So the percentage of heap used here. So I'm using, in this particular case, between about 36 to 40% of my heap is being used for characters. And that is pretty typical in a Java environment. So the top two are generally going to be chars and bytes. But what you would also see here is if you got some class which was utilizing memory and you've got a memory leak, then you'd start to see that particular class bubble up. So you'd see the number of objects increasing, you'd see the percentage of memory used increasing. And what we've got is we've got the ability to take a snapshot, and I'll just click that, take a snapshot here. And that's the snapshot that I just took. And if I go into the heap snapshots view, I can select a couple of those and then perform a diff. So one way to basically highlight differences, because obviously, you know, you're monitoring this information. The heap is changing all the time, but you might detect a class which you believe is causing some problems, and then say, okay, you know, I'm going to take a couple of snapshots here, and I'll just compare things. So this is a really, really useful screen. It will compare the two snapshots for you. You can see we've just called it left and right here. But you can see the various different classes with the number of objects which have been created, and the difference in size, both in objects, number of objects, and the delta size in terms of heap utilization. So very, very useful in order to be able to drill down and and look for memory leaks. Another feature we've got in here is if we see here on the right hand side, there's a little icon, and behind that says GC roots. If I click on GC roots, so basically many people think that garbage collection, that the way that it works is it collects and discards dead objects. In reality, garbage collection is doing the opposite. So what it's doing, live objects are being tracked, and anything which isn't tracked is designated as garbage. And the GC roots, basically, this is showing everything which is currently tracked. So you can think of this sort of as a tree, and within that tree, there's different types of information which are part of GC roots. But again, using this, you can drill into the GC roots for your application for a specific class, and then you can see the memory, exact memory utilization, and how many objects are being created within that GC root component. So basically you can see exactly which memory is being used. So again, very, very useful in isolating and detecting memory anomalies or memory leaks, memory issues, basically.
So these are a lot of amazing features, David. I know we need to wrap up in about 10 minutes. So what are there any other of the new features that are really stand out for you in this release?
Okay, so the other thing that I'd like to show you, which is really, really amazing, is the debugger. And to show that, I've got a little example, little JSP page here, and I'm just passing a string into that. And if I pass a string in, all this little JSP page does is just do a string length. And so I've got 19 characters here. If I remove that argument and then call that, I get a null pointer exception, essentially because this thing was expecting an argument and we didn't pass one in. So let's just jump into Fusion Reactor and take a look at what we've got. So if I go into the error history, so this is showing me all the errors which came up, which is also really, really useful because you don't need to go hunting for them. You can just find all your errors here. I see the top one is nullpointer.jsp. And if I drill into that, I see all the transaction details, which we looked at before. But I've also got a new tab here called error details. And if I click on that guy, I can see Fusion Reactor tells me that I got a null pointer exception, and it tells me this was caused by. And this is the stack at the points that this error occurred. And again, like we saw before, if I click on that particular method, lo and behold, it will instantly decompile it, and it's actually highlighting the line of code where that problem occurred. So just take a second just to sort of take that in. So Fusion Reactor knows that we had an exception. It's pinpointed the line of code which caused the exception. And if I click here, I just set a breakpoint. So imagine this is your production environment. Something's just occurred. You just had an exception condition. You could literally go straight into Fusion Reactor, pinpoint the line of code, set a breakpoint, and if I close that now, and then I run this again, watch what happens. So now you can see this says connecting up at the top, so this tab didn't run through to completion. And if I go into Fusion Reactor, I now see a little bug up at the top. If I click on the bug, this is the thread which is currently running. And I don't know if you can see that. It's actually, it says timeout in 40, 39, 38. This is counting down. I've given myself 60 seconds in order to intercept this thread. So I can change that by default, but at the moment it's configured at 60 seconds. And within that 60 seconds, if I click on the debug icon, boom, I'm straight into a full-blown IDE-style debugger in production, inside Fusion Reactor. There was nothing else to install, nothing else to configure on the JVM. This is Fusion Reactor out of the box. And you can see here, before we were seeing the actual Java code, so the decompiled Java code. Now I'm seeing my source code. So you can tell Fusion Reactor, where does my source code exist? And it will basically figure out, it will translate the points in the Java code where that error occurred and relate that to a line within your actual source code. And this is a JSP file here, but this works exactly the same for ColdFusion. So if you pointed this at your ColdFusion code, then it would pop straight up with, this was at line such and such in your ColdFusion. And I can see all the various different frames here. So again, I can scroll through these, and this is a really amazing thing because very often defects will occur at some point higher up in the stack. But that issue actually propagates down and manifests itself at a lower point. So, you know, by being able to scroll through the stack and also see all the different variables, and these are all the scope variables at that point in the stack, I'm getting amazing insight here into what my application's doing. You know, I'm debugging it in production and safely and with very, very minimal overhead. And I can even go in and you'd see the reason why this broke is argument was null. And if I go in and modify that to be Michael, and then I hit resume, then that will run through to completion, and lo and behold, there's Michael. So I was even able to modify a variable on the fly. Really incredible capability that you've got here. What else can we do? If we run that again, let's see what happens. Boom, it failed. So why did it fail this time? It failed this time because we instructed Fusion Reactor to only halt one single thread. And this is really one of the differentiators. One of the reasons why normally you wouldn't use a debugger in production, there's two key reasons. The first reason is performance. If you try and connect a debugger remotely, let's say with Eclipse, then that would work. But there's a debug transport protocol, which is exchanged between Eclipse and between the server that you're debugging. And it's really, it's the processing of that debug protocol, that's what actually causes the main performance hit. And we don't have that at all. Why? Because we're integrating into the debugger, which is built into Java itself, and we're going in through the JVM TI interface, so through the tools interface, which is a very difficult, very tricky thing to do. But by doing that, there is no protocol because we've coded directly at it. So if the debugger's not running, the overhead is zero. It's zero. There is no overhead.
Wow. That's genius, David.
It is. Well, I don't know whether it's genius, but it's, you know, it's damn clever. And the
so
other,
if folks wanted to try out Fusion Reactor, is there a demo edition they can try it? Or?
Yeah, sure. Yeah, there's a 14-day trial that you just go on to Fusion Reactors onto our webpage, reactor.com, and you can see here there's a download page, and if you click on the download page, all you need to do is enter your email address, tell them that you're not a robot, and then click generate trial key, and that will instantly generate you a trial key. It will also send you that trial key to your email address, and then you download the software. So we've got automated installers for Windows, Linux, and Mac, 32 and 64 bits. We've also got Fusion Reactor as a Java agent. So you can do the jar file install. You've got to modify the Java args, but it's dead simple. You can literally, you know, install Fusion Reactor in a couple of minutes. If you're using the debugger, there is a separate library for the debugger. So you get that here as well. So you need both the jar file and the debug library. But if you use the automated installer, it does it all for you. So a lot of people, a lot of times, the CFers, they're running the automated installers. And that works really good. And if you go down to the bottom, there's a bunch of videos. So here it's showing manual installation on Tomcat. There's a video on how to, software activation is usually automatic. If you've got outbound internet access, it's all automated. If you don't have outbound internet access, then you need to do a so-called manual installation. And there's a little video on how to do that here, but it's dead simple. Usually you can get Fusion Reactor installed, up and running in a couple of minutes. And we've got various different tutorials. There's a bunch of webinars that we've got. We've got various different videos that show you the product and the different features. We're on YouTube, so if you go onto the YouTube channel, that's actually not the, that is just a straight click to YouTube. But if you go up to the top, that's our YouTube channel. So you can see here that there's a bunch of videos, and these are all broken down into different video playlists. So we've got stuff focusing on the debugger or the profiler, all the different features that we've got. We've got videos on troubleshooting, all kinds of different things.
That's great.
That's great.
And then if people want to buy it, it's $39 a month for the regular edition, or $79 for the ultimate.
Right. So pricing, if you go into pricing, so we offer two types of license. There is a subscription and a so-called perpetual, pay once, own it forever. So we believe in giving people choice. So if you do subscription, you can either do monthly or annual. If you do annual, you get 2 months free. So standard starts at $39, ultimate at $79. So if you buy a year, it's $390, $590 for enterprise, or $790 for ultimate. And if you do the pay once, it's $999, $14.99, or $19.99 for ultimate. Each of the perpetual licenses contains 1 year's maintenance, and maintenance following that is optional, and it's basically 20% of the product price. So it's $199, $299, or $399 for ultimate. And you can see we've got all the different, we show all the different features. We've got the different editions where you can look at what you get in each different edition. So the debugger, profiler, the line profiler, and the memory profile, those are all ultimate features. And then you can see here what you get in the enterprise edition with the dashboard. You get the JMX MBean metrics. You've got the CloudWatch, the system monitor. We do a bunch of reporting, daily, weekly, and monthly reports. We've got a mobile application which gives you unlimited access to Fusion Mobile. That's all included in enterprise, and then all the core sort of metric-y features. Also, crash protection is also included in standard.
Right.
And you'll see we've got here under the C features screen. We've just added this for this release. This is really nice. This gives you basically a bunch of screenshots of the different areas of Fusion Reactor. And I think there's over, at least, I think there's 40, I think we've got 42 different screenshots here. And yeah, you can drill into these, take a look at them. If you click, for example, click on dashboards, then it'll show you all the dashboard views. If you click on crash protection, you'll see some information on crash protection. Click on JDBC, you'll see the JDBC stuff. So all pretty straightforward, but gives you a really nice overview of what Fusion Reactor delivers.
Wow. Well, this is great. I really appreciate you showing us all the new stuff in Fusion Reactor 7. It's pretty almost overwhelming how much stuff you've packed into this.
Yeah, it's not all. It didn't all come in Fusion Reactor 7, but like I said, there was I think over 120 different either major features or improvements or bug fixes that went into Fusion Reactor 7. So there's really a lot of stuff.
Great. Well,
yeah. Okay.
So we'll look forward to learning more about Fusion Reactor Cloud in another show. And I appreciate you coming on the show today, David, and showing all this. I know it must be pretty hectic having only released it a week ago.
Yeah, it was pretty hectic, but it's good. Should I hand over to you? Stop sharing?
Yes, yeah, let's stop screen share.
Yeah, I'm not sure.
I have another interview I'm doing with Rakesh from Adobe in about 1 minute, so we do need to wrap this up.
Okay, then. Okay, well, thanks very much. Thanks for having us, and yeah, I appreciate it.
Yeah, it's always good having you. Hopefully we'll get Daryl on in a future episode as well. So
okay, that'll be great. Okay, thanks a lot.
Okay, thank you, David. Bye.
Bye-bye.